Chapter 9 takes our ideas from Chapter 8 about quadratics and parabolas, and in Chapter 8 we spent a lot of time, the majority of the time, graphing the parabolas, graphing quadratics. What we're going to do in Chapter 9 is we're going to find the values of x. We're going to actually solve those quadratics to see what the values of the variable are. So if you remember back from Chapter 8, we talked about quadratic equations. And we said that a quadratic equation is a nonlinear equation because it's not a line, and it's written in the form ax squared plus bx plus c equals 0. Obviously, the a value can't be 0 because if the a value were 0, then you would just have a linear because that whole x squared term would disappear. One thing that we actually did in Chapter 7 related to solving quadratics was we factored. That's one way that you can solve quadratics. I didn't make a big deal about it, but when we were putting them in the double bubble and doing the GCF, right, all of those steps, and finding the values of x, we were solving them. So that's the idea behind what we're going to do. We're going to look at other ways besides factoring to solve these equations. One way that you can do it is by using our idea from Chapter 8 by making a graph. The first step is to just get it in standard form, ax squared plus bx plus c equals 0. Sometimes you just need to move things around or simplify to get it into this form. Then you use whatever method you need to from Chapter 8 and you make the parabola, you make the graph. And then the final thing you do is you look at where those x-intercepts are. Because the solutions, or what we called the roots back in Chapter 8 of that parabola, are the x-intercepts, which therefore are the values of x that make it equal to 0, right? Because on the x-axis, you have a y value of 0. So you make the graph, you look at the x-axis, you find out where it crosses, and that spot where it crosses, those values are the answer. All right, so let's do it. The first thing that we're going to do in example 1 is look at the equation and get it in standard form. So the first thing that I need to do is just get that 3 over to the left. So I get x squared plus 2x minus 3 equals 0. So what I'm going to do is I'm going to graph the parabola y equals x squared plus 2x minus 3. So now let's go into our memory banks and brush some cobwebs off. The way that you would graph this, you can do it a couple ways, but the easiest one that when it's in this form, standard form, is to find that symmetry line, the vertex. So I'm going to use x equals negative b over 2a. So that gives me negative 2 over 2. So the vertex is at negative 1. So then the next thing that you do is you make a table. So I'm going to make an XY table. I'm going to put negative 1 in the middle. I'll go 2 to the negative and 2 to the positive. Pause the video, fill in the table, and press play when you have it. Now, if you know what the answer is already, just kind of go along because it says we have to use graphing, so I'm not going to spoil it for you. But let's make our grid. There's the x-axis and the y-axis. And let's plot our points. I'm just going to label this parabola y equals x squared plus 2x minus 3. The answer is the x-intercepts. So it's crossing the x-axis right here. So the values of x are 1 and negative 3. Now, if you want to, you can plug it back into the equation all the way up here and see if you get a true statement. You can always do that with any equation. Back here in example 1, the title of the example said 2 real solutions, and it crossed 2 times. All right, so now it's your turn. Remember, the first thing you're going to do is you're going to move that negative 16 over to the left. Then you're going to find the points, you make the parabola, and then where it crosses is the answer. So when you have all of example 2 done, press play, and I'll reveal my solution. Here's what I got for example 2, and there was only one place where it crossed. And actually, before you go on to example 3, let's talk for a second. In example 2, it said one real solution, and it crossed one time. So it would make sense that example 3, now that you look down, it says no real solutions. It's probably going to have no intercept. So what do you think a parabola like that would look like? Describe that in your mind. What would it look like if there's no solutions? When you have that in your mind, pause the video, do example 3, but before you do that, I'm going to catch you from making a mistake that's going to be complicated. Instead of bringing everything over to the left, since this would be the leading coefficient and it's negative, bring this term over to the right. Okay, pause the video and try example 3 now. Was the picture in your mind similar to the picture that we got? Only you can answer that. But so what we write when it has no x-intercepts is we write no solution, because there's no value of x that makes the parabola or makes the equation equal 0. Remember, another word that we used for x-intercepts was zeros. So sometimes it'll say find the zeros, which is another word for find the x-intercepts or the roots. So this next example, example 4, gives us a graph. They even tell us the equation, and they want us to find the zeros, right? So really all they're asking is, what are the x-intercepts? It's super quick. Obviously, when you have a graph, all you do is you look and you say the values where it's crossing the x-axis. So the x-intercepts, or the zeros, are -1, 2, and 3. Now you could factor this if you wanted to. You could factor this polynomial. Obviously, you would see the first part would give you 3. And if you factor this trinomial into the double bubble, when you got down to the very end, you would get -1 and 2 as the other one. So that's another way to do it.